We are going to talk about finding areas of curves under the x-axis. In the previous tutorial, we solved this example. We had to find the area of the shaded region, which was under the x-axis. We used the definite integration and we obtained a negative value. However, we said that the area should always be positive, so we took the positive value and we said that it is the area. Pay attention. Sometimes not the entire curve is below the x-axis. It could be like this. On one side, the curve is above the x-axis, while it is below the x-axis on the other side. We need to calculate the area on both sides. The following example shows that great care must be taken if you are trying to find an area which straddles the x-axis, such as the shaded region below. The region is bounded by the curve with the equation y equals x plus 1 into x minus 1 into x. When we expand, it will be a cubic function, x cubed minus x. When calculating the area here, if you take the definite integration starting from minus 1 to 1 for the curve x cubed minus x, the final answer will be 0. What does the 0 mean? As you can see, this part here has an area, so it cannot be 0. That is why when we have two parts above and below, we cannot take everything together. In this kind of exercises, we need to divide the curve into two parts. The first part is below the x-axis, this is region 1, while region 2 is above the x-axis. In region 1, the integral was from 0 to 1, so they only calculated for this part and the answer was minus 1 over 4. However, we changed the answer to positive, so 1 over 4. Now for region 2. Integral y dx, where the x starts from minus 1 and ends at 0. So they divided the curve. A part that is below the x-axis, the answer was negative and they changed it to positive. Also, they calculated the definite integration for region 2 from minus 1 to 0 and the answer was 1 over 4. So, the area of the shaded region actually is area of region 1 plus area of region 2. However, we multiply region 1 by minus 1 in order to make it positive. The area is 1 over 2, which is logical because it is positive and not 0. This is how we work when we have an area under and above the curve. Then we add the answers of the two parts to get the total area. For examples of this type, you need to draw a sketch in order to know when it is above and when it is below, and to define the x-axis intercept, which we use in the definite integration. Unless 1 is given in the question. That means sometimes you will be given the curve and you just need to define the region and know when to multiply by minus and then to add the areas.